given that sum of the terms r is equal to 1 to n tr, which is given as 2n minus 1 into 2n plus 1 into 2n plus 3 into 2n plus 5 upon 64. Then we need to find the limit n tends to infinity. This summation 1 r is equal to 1 to n 1 upon tr. So here we have Sn is equal to 2n minus 1, 2n plus 1, 2n plus 3 into 2n plus 5 upon 64. Let us find the term. For this we need to find Sn minus 1. So we can add 2 times of n minus 1 minus 1, 2 times of n minus 1 plus 1, 2 times of n minus 1 plus 3, 2 times of n minus 1 plus 5 divided by 64. So which is equal to, and here we can write 2 times of 2n minus 2 minus 1, that is 2n minus 3, and here 2n minus 2 plus 1 is minus 1, and here 2n minus 2 plus 3, that is 2n plus 1, and here we can add 2n plus 3 divided by 64. So that we have Sn minus 1, which is equal to Tn. We can take common 2n minus 1 and 2n plus 3 and 2n plus 1. These are the terms we can take common, divided by 64, and the remaining terms we can write 2n plus 5 minus of 2n minus 3, and simplifying we can get, and here we can write 2n plus 5 minus 2n plus 3, that is 8. So 8 upon 64 into 2n minus 1, 2n plus 1 and 2n plus 3. 8 times. So we got 2n minus 1, 2n plus 1, 2n plus 3 divided by 8. Then 1 upon Tn, which is equal to 8 upon 2n minus 1, 2n plus 1 and 2n plus 3. Let's take 1 upon 2n minus 1 common. And here the difference between 2n plus 1 and 2n plus 3 is 2. So let us write 4 as 8 as 4 into 2. So 4 here, and here I can add 1 upon 2n plus 1 minus 2n plus 3. So that the difference of these two numbers is 2 and the denominator is 2n plus 1 into 2n plus 3. So we can add 4 upon 2n minus 1 into 2n plus 1 minus 4 upon 2n minus 1 into 2n plus 3. That is 4 taken common. Or here the difference between 2n minus 1 and 2n plus 1 is 2. So I can take only 2 common. So if 2 is taken common, so you can add 1 upon 2n plus 1, 2n minus 1 minus of 2n plus 1. And again here, the difference between 2n minus 1 and 2n plus 3 is 4. So you can just write, we can write 1 upon 2n minus 1 minus 2n plus 3. Now applying summation, So we get summation r is equal to 1 to n 1 upon tn is equal to, so we can write 2 times of when r is equal to 1. So here we can write 2 ones are 2, 2 minus 1, 1 upon 1 minus 1 upon 2 ones are 2 plus 1, 3, and again plus if r is equal to 2, so r is equal to 2, we'll get 1 upon 2 2s are 4 minus 1, 3, minus 1 upon 2 to the 4 plus 1, 5, and so on. And again here minus of the second term 1 upon, if we take n is equal to 1, so 2 ones are 2 minus 1 is 1, minus 1 upon 2 ones are 2 plus 3, 5, plus 1 upon 2 2s are 4 minus 1, 3, minus 1 upon 2 to the 4 plus 3, 7, and again plus 1 upon 2 3s are 6 minus 1, 5, and minus 1 upon 2 3s are 6 plus 3, 9, and so on. So here we can see that this minus 3 plus 1 by 3 gets cancelled, and again minus 5 will be getting cancelled with another term, so you'll be getting only 2 times of 1, and minus here 1 upon 5 will be getting cancelled with here, and 1 upon 7 also will be cancelled for the other terms, and 1 upon 9, so we'll be left with only 1. As n tends to infinity, here we can write as limit n tends to infinity summation 1 upon tn, where r is equal to 1 to n, so we can expand it and we can say that the rest of the terms will be cancelled, so the remaining terms are only 1 minus 1 plus 1 by 3, so which is equal to 2 minus 1 minus 1 by 3, that is 1 minus 1 by 3, 3 ones are 3 minus 1, that is 2 upon 3. So as n tends to infinity, the summation can be taken as only these 3 terms, so 2 minus 1 minus 1 by 3, so we'll be getting the answer 2 by 3, which is our option C.